viewers, welcome to my channel and thank you for watching the videos. In this video, question 5A of 1996 UPSC CSE Maths Optional Paper 2. Same question has been appeared in 1994. So just analysis based question. Suppose that Z is the position vector of a particle moving on the ellipse. C is equal to Z is equal to A cos omega t plus I B sin omega t, where omega and a, b are positive constants. A is greater than b and t is time. Determine where the velocity has the greatest magnitude and second, the acceleration has the least magnitude. So this type of question has come in 1996 also, and only the little bit frame of the question is different. Instead of omega, there it has been used lambda and capital A, capital B in place of small a and small b, but otherwise question is same. So here we will draw a ellipse which is given by this equation. So let's see. So we take the other formulation of the question which appeared in 1996. Sketch the ellipse C described in the complex plane given by Z is equal to A cos lambda t plus I B sin lambda t. So instead of omega, here lambda has been used, and instead of small a and small b, capital A and B has been used. A is greater than B. And if C is the trajectory of a particle with the zt as the position vector of the particle at time t, identify with justification. The two positions where the velocity is minimum, the two positions where the acceleration is maximum. So first, as I said, we will draw the figure. So here we take this equation, which is well-known equation. We know that x square upon a square plus y square upon b square is equal to 1. This we know, equation of ellipse. X is equal to here a cos lambda t in this question, and y is b sin lambda t. So when we take t, which is increasing from 0 to first pi upon 2 omega, it means it is going from, it's a normal ellipse with major axis 2a and minor axis 2b. Why is it so? Because before knowing it, we need to draw it, and drawing is that we are starting from 0 and this is moving in this direction. Ellipse is there, this we know from the question itself, and it is moving to pi upon 2 omega. It means it reached to this point, B point. Then pi upon 2 omega to pi upon omega, or lambda in place of lambda. Omega both are interchangeable, so please don't get confused. Lambda or omega are same thing. So it is coming up to a dash point, and then it is going from 3 pi upon 2 omega to pi upon omega to 3 pi upon 2 omega, and then 3 pi upon 2 omega to 2 pi upon omega, reaching to point A. So that way I am repeating, it is moving from 0 to pi upon 2 omega, reaching to point B, pi upon 2 omega to pi upon omega, reaching to point A dash, pi upon omega to 3 pi upon 2 omega, reaching to B dash, and 3 pi upon 2 omega to 2 pi upon omega, reaching to point A. It's moving counterclockwise direction. So figure is clear. Here we take a point Z in same question. The formation will be, so this is Z. We take a point Z on the curve and we draw a line from here to here. So this point is Z, which is intersecting on the curve. So this point is Z point. And angle is omega t, or lambda t, whatever. This is capital B or small b according to the question. Both questions I am considering. Here it is small a or capital A, 0 to A. I hope figure is clear. X-axis is there. You know this is x-axis and this is y-axis. Fine, now we want to find out the speed, and velocity will be dz upon dt. Differentiate z with respect to t. So dz upon dt is this after differentiating with respect to t on right hand side also, and speed will be magnitude of velocity, that is mod dz upon dt. When we take mod, it becomes a square lambda square sine square lambda t plus b square lambda square cos square lambda square t. Of course square root is there. Now we just simplify it and make this, that a square minus b square. We have written this cos square lambda t in form of 1 minus sine square lambda t. So this becomes a square minus b square, and lambda we have already taken out, sine square lambda t plus b square. So we have to find out according to the question minimum one. So for minimum or least magnitude, where sine omega t or sine lambda t is equal to 0, and where it will be at points a and a dash, and for maximum, where sine omega t or sine lambda t will be 0, or we can say that this whole term a square minus b square is positive. So where it will be at the points of a and a dash, and where xt is equal to plus minus a or small a we can have, and yt is 0, means on the major axis where we have point a and a dash. And for suppose in the question it has been asked that maximum, which has not been asked, then it will be greatest magnitude, where sine omega t will be plus minus 1, and that will be the point where the points which are on minor axis b and b dash, where yt is b and capital B, we can say small b or capital B, and xt is 0. Now we want to find out the acceleration. So acceleration is second derivative of dz. So d square z upon dt square, we are finding second derivative, we are taking magnitude of it. You know how to do it. A square plus, if x plus iy, it becomes x square plus y square under root, the magnitude. If the point is x plus iy, magnitude is acceleration is second derivative d square z upon dt square, and which is equal to this much. And if we have a point, suppose x plus iy, magnitude is under root x square plus y square, that is the formula has been used here, and we got the magnitude, which after simplifying sine square lambda t in terms of cos square lambda t, we got this much. And it has to be maximum, for maximum, because in the question it has been asked, it is cos square lambda t should be 1, or cos lambda t should be plus minus 1. So the points will be a and a dash, and of course in that case a square minus b square is greater than 0, and for minimum cos square lambda t is equal to 0.